Okay, there's one more part to graphing quadratic functions, and that is that we could find x-intercepts. So we'll be doing that today. All of those things that we've been doing, axis of symmetry using negative b over 2a, we're still going to do. It's the mirror image. The vertex is the turnaround point. We're still going to use negative b over 2a, and we're going to substitute that value in to get y. We're also going to look at this and determine if the a is positive or negative. If it's positive, it's the minimum. If it's negative, we know it's a max. We're going to continue to find those helper points, and we're typically going to plug in 0 if at all possible. But the one more thing that we're going to do is find the zeros. And when we're finding the zeros, we're going to do that by factoring, by square rooting if there's no bx term, or by using the quadratic formula. And then we'll have to transfer that quadratic formula into a calculator to get the decimal answer. So what we're going to do is all of those things: find the axis of symmetry, get the vertex, figure out how it opens, find the helper points and the mirror points. We're going to plot the zeros and then just connect those all together. So this is the types of blanks we're going to fill, and notice they just keep getting a little bit longer. It's still the same process every time. So let's go ahead and find our vertex, negative b over 2a. We'll use this to find our axis of symmetry and our vertex. So negative b would be negative negative 2 all over 2 times 1. So we end up getting 2 over 2, which is a 1. So my axis of symmetry is 1. My vertex is 1 comma something. We're going to figure out that number by plugging in the 1. 1 squared minus 2 times 1 minus 8. So that would be 1 minus 2 minus 8, which would be a negative 9. So we have 1, negative 9 that we'll plot. We're going to know that it opens upward because the a is positive. If it opens upwards, that means it has a minimum. The minimum value happens to be negative 9. The domain is always all reals. Since we know it opens upward, negative 9 is the smallest value, so y has to be greater than or equal to negative 9. The helper point is 0 comma something, so when you plug in your 0 up here, 0 minus 8, we get 0, negative 8. 0, negative 8 is right here. The mirrored image of that would be at 2, negative 8. And then here's the one new part, finding the x-intercepts. So in order to find the x-intercepts, what we're going to do is we know that y is equal to 0. So we're going to say 0 equals x squared minus 2x minus 8. We're going to hope that it factors. If I think it's factorable right away, I'll go ahead and do it. If I don't, I'll just use quadratic formula. This, I'm pretty sure it's factorable because 4 and 2, that will give me a negative 2. If that is a negative 4 and this is a positive 2. So when I solve these, x minus 4 equals 0 and x plus 2 equals 0, I end up getting x is 4 and x is negative 2. So my x-intercepts are 4, 0 and negative 2, 0. So I've got a couple more points I can put on here, 4, 0 and negative 2, 0. And then I can use all 5 of those points to make a much better picture of my quadratic function. I will get started on the second one, however, I won't get it finished during this video. So the vertex is negative, we'll use negative b over 2a to find. Negative b is negative 4 all over 2 times 1. So I get negative 4 over 2, which would be a negative 2. Axis of symmetry is negative 2. X equals negative 2. Vertex is negative 2 comma something. So when you put in negative 2, you get negative 2 squared plus 4 times negative 2 plus 2. So we get 4 plus negative 8 plus 2. That would give me 6 and negative 8, which is a negative 2 also. So this gives me a negative 2. My vertex then is negative 2, which is right here. The a is positive, so I know it goes up. Since it goes upward, this is a minimum. The minimum happens to be negative 2. The domain is all reals, and because it's going up, the range has to be that y is greater than or equal to negative 2. The helper point is when I put 0 in for the x's, so I get 0, 2. 0, 2 is right here. Going the same distance away 2 units, I get my other helper point of negative 4, 2.